There were many scientists that tried to discover a logical way of organizing the periodic table. Dmitri Mendeleev was the first one that actually put it in some kind of order that was sustainable. Okay, so he organized them according to increasing atomic mass, which was important, but just as important was that he paid attention to the properties and characteristics of these elements as well. So if for whatever reason the properties were not fitting according to increasing mass, he simply changed them and put them so that they were still next to where they should have been. He also did this kind of cool thing where he left blanks in the periodic table. So he didn't try to just shove everything that was already discovered together. He left blanks because he said, you know what, something should fit into there. We just haven't found it yet. So he left it blank. And what was really cool is that based on where those blanks were left, he was able to tell us pretty much what those characteristics of that element was going to be when he found it. For instance, he left a blank for an element that he said should have about an atomic weight of 72. It should have a high melting point, should be a slightly dark gray color, have a density of about 4.7. Well, years later, when germanium was discovered, sure enough, its atomic weight was pretty close to 72. 947 kelvins is a really high melting point, and it was grayish white in color. So not dark, but still gray, and it had almost exactly the density that he had said it was going to have. So just by the way he organized the periodic table, he was able to predict the properties of unknown elements. As awesome as Mendeleev was, being the father of the periodic table, Henry Moseley is the one that actually gave us the one that we use today. By the time that Henry Moseley came along, we knew about protons and neutrons, and so Henry Moseley used X-rays to determine the atomic numbers, which we know is equal to the number of protons, to rearrange the periodic table. So our modern periodic table is actually based off of the original one that Mendeleev made and was corrected and fixed by Henry Moseley, so that we are now in order of increasing atomic number, not necessarily increasing atomic mass. And this way the properties line up automatically. Okay? So the one he gave us has 7 periods, and it has 18 groups or families. Okay? So if we don't know what a period is, the periods go across in rows, and the groups go down in columns. Okay? And we can group these properties even farther by going, okay, well, we know our alkali metals, we know our alkaline earth metals, and we know that our transition metals, which do kind of extend into here, are all metals. And everything over on this side of the periodic table, which includes our noble gases and our halogens, okay, and all these lovely guys over here like oxygen, are our nonmetals. Our metals and nonmetals are separated by this lovely stair-steppy right in here, which includes some of the elements that surround the stair-steppy. So they're not really metals, and they're not really non-metals. They kind of have properties of both. So they're metalloids, okay? We can then come down here to the bottom, and these lovely guys are actually metals as well. They're called rare earth metals, which means that they're not something that you're going to find every day. They're rare, okay? So in recap, Mendeleev made the original periodic table, organized it according to increasing atomic mass and properties and characteristics. Moseley fixed it the way we know it now based on increasing atomic number.